All right, so day 7 today, everybody ready to go? Yeah. All right, here's example 1. All right, any idea where to start? Yes?
5.
Good, so we can separate the radical in the back for that fraction. So we can take the square root of the 3 and the square root of the 5. Yes?
Multiply by 5, top and bottom.
Multiply by what?
Square root 5.
Square root 5. So we're going to multiply the top and bottom by the square root of 5 because we cannot leave the square root 5 in the denominator. So this is square root 15 minus, what do we get in our numerator? Square root 15 over in the denominator, we get a 5. Good. So I'm going to rewrite this real quick. I'm going to write it as 1 square root 15 minus 1/5 square root 15.
Why?
Why would I rewrite it like that?
You get the 15 alone.
Yeah, so now it's a little easier to see that these are radicals that are alike, right? So I'm going to subtract their coefficients. Well, 1 is the same thing as 5 over 5, right? So what's 5 over 5 minus 1 over 5?
4/5.
So this would be 4/5 times the square root of 15, and we can just put that up top.
Why?
What?
Why did you have the 5 instead of the 15?
So to me, like this step right here, I'm not really sure how to subtract these.
Put it over 1.
I guess the other way to do it would be to put it over 1 and then do common denominators. So multiply by top and bottom. Does that make a little more sense? So if I make this one 5 and this 5. Okay, yeah, same thing. So 5 square root 15 minus, yep, that works. So we still end up with 4 square root 15 over 5. I think I like your way better, actually.
You're good.
Thanks. Thank you. That's a good team effort. If you get 5, how do you want to write it?
Is it okay if I write it 4/5 square root 15?
That I'm okay with that.
Because then you would just subtract the 5 and the 1 and you would get the 4 and just keep the 15 and the 5.
Right. Either way, you get the same thing. Good. I like it. What are your questions? Yes, ma'am.
So with I did it weird first, which is obviously wrong, but so you always have to do it you always have to make sure that there's no denominator that's a radical.
Right. You got to get.
Do anything else?
Sometimes it's easier to do it first. Sometimes it's easier to do it last. On this one, I didn't really know what else to do, so that was kind of just like, hey, let's see what this does, and it gave me like radicals, so it worked out.
Okay, because what I did was I made it so 15 was a radical, and then I made it into a fraction, multiplied each side by 3 so it could be subtracted, and then I got 7,005.
Hold. All right, what am I going to do?
Multiply.
Put a radical on both of them.
Multiply by
Yeah, so I'm going to start by just breaking this guy up.
Are y'all gonna stop or not?
No, shut up.
Stop kicking my ch-
Okay, now what?
multiply by square root negative square root 7.
Just regular. That's just, think of it as a minus sign. So we want to get rid of the square root of 7 in the denominator. So I'm going to multiply top and bottom by square root 7. So I have the square root of 21 minus square root of 21 over, what am I going to get in the denominator? 7. Good. All right, let's do it the way you guys were thinking. Let's make that over 1, and then let's get common denominators. So what would I multiply it by? 7 over 7, right? So I get 7 square root 21 over 7 minus square root 21 over 7. So it's like 7 minus 1, which is?
6.
So 6 square root 21 over 7. You can do a factor tree for 21. You'd get 3 and 7. Those are both prime numbers and neither one of them repeats, so you can't really do anything with that. And then I would double check, like 6 over 7 doesn't simplify either, so we're good. Questions? All right, where do you guys want to start?
Multiply by square root of 7.
Let's split them up first. So yeah, you want to multiply the square root of 2 over the square root of 7 by square root of 7 over square root of 7? Is that what you're saying to me? Okay. So I get square root 14. I'm going to put it over 1. Minus, up top, I get square root 14. On the bottom, I get square root 7 times square root 7, which is just going to give me 7. All right, common denominators would be what? 7. So I'm going to multiply this guy by 7 and 7. So 7 square root 14 over 7 minus square root 14 over 7. What am I going to get?
7 square root 14.
I'm completely different.
Questions?
Wait, so whenever you multiply the
Any ideas on example 4? Yes, ma'am.
Multiply both of them by the denominator.
Yeah, so the first one, first of all, I'm going to break it up, square root of 3 over square root of 10, square root of 10 over square root of 3. Then this one's going to get square root 10 over square root 10. This one's going to get square root 3 over square root 3. Okay? So I end up with square root 30 over, that's going to give me 100 in a square root, which is just 10, right? Minus, in the back I have square root 30 over 3. Okay.
LCD of 30.
Now I got to get the LCD of 30. So what do I multiply the first one by?
30 over 3.
3 over 3. What do I multiply the second one by?
10 over 10.
10 over 10. Okay?
-7 square root 30.
So -7 square root 30 over 30. Can I do a tree for 30 in the radical?
No.
I mean, you can do a tree, nothing's going to happen. What about the 7 and the 30 that are outside the radicals? Do those simplify?
No.
Nope, this is actually it for this one.
I don't know what I did.
When you say simplify, what do you
Like-
mean?
Like, you do simplify the square root of 50 and the square root of 32.
Trees.
Okay, so trees, yes. So 2 and 25, 2 is prime. 5 and 5, prime and prime. The 5 comes out. The 2 stays in. All right, what about the 32? 8 and 4. 2 and 2. 2 and 4. 2 and 2. So I actually have 5 2s. 1, 2. So 2 of them are coming out.
2.
So that's 2 times 2 is
4.
4. square root 2 minus, what should I do in the back?
Start by splitting the fraction and then multiplying by square root 2.
Yeah, so we can multiply top and bottom by square root 2 over square root 2. So I get square root 2 over the square root of 4. And what's the square root of 4?
2.
2. Good.
Put it all over 2.
All right, so you want to get common denominator of 2? So I'm going to make these each a 1. So multiply by 2 over 2 and 2 over 2.
10.
10 square root 2 over 2 plus 8 square root 2 over 2 minus 1 square root 2 over 2.
Is 17. Square root 2 over 2.
17 square root 2.
All right, and can I simplify any part of that?
No.
Nope, that is it.
Doing the factor trace on 28 and splitting the fraction.
Wait, I'm not done.
Okay. My eyes as the teacher go right here. Why? That's a perfect square. So that can come outside to play with the 6. What is 6 over 2?
3 over 1. 3.
Yeah, so when that comes out, it's still in the denominator. So it's like a 1/2 that's coming out, or you could think of it as like a divide by 2 that's coming out. So that's going to give me 3 square root 7 for my first term. How do you feel about that?
Awesome.
Okay. This one, 4, 7, 2, 2. The 2's come out. So 6 square root 7 minus, yeesh. 1 is a perfect square.
What?
And I need to get rid of the square root of 7, right?
Oh, no, 1's a perfect square.
So
Square root 7 over 6.
I still have the 10.
10.
Square root 7. What's that?
So I'm going to put the 10 in my numerator. Since it's a whole number, you could write it over 1 if you're unsure of why I did that. We already said the square root of 1 is 1, and 1 times square root of 7 times 10 is just 10 square root 7. And then square root 7 times square root 7 is square root 49, and that turns into a regular 7. Okay? Then what?
Put everything over 1.
Everything over 1. Wait, let's do Stella's trick. Let's combine these. So this is going to be 9 square root 7 over 1 minus 10 square root 7 over 7. Now what?
Everything over 1. Multiply by 7.
Multiply by 7 over 7.
63.
So 63 square root 7 over 7 minus 10 square root 7 over 7.
53 square root
That's
7
one
over
big
7.
number.
53 square root 7 over 7.
Doesn't simplify.
Does 7 go into 53?
No.
Let me see.
Wait, 5.
Nope.
Yes,
That's the answer.
Why is it so big? No, pause.
I don't know. Questions?
We're having homework this week?
Yes.
No.
All right, here is example 7.
Wait, you go backwards. I don't think 10 likes this. Ooh, 2 is a. No, there is.
Start by multiplying square root 5 times square root 5.
Yeah, so I'm going to multiply top and bottom by square root 5 over square root 5 back here. So you can see where we're going. This is probably going to end up being a fraction, right? So that's going to be square root 10 over the square root of 25, which is just 5.
5 denominator.
Now what?
Denominator.
Can't you subtract the square root times?
Well, you need like radicals and you need common denominators. So I need to multiply this guy by 5 over 5.
5.
So 5 square root 10 minus square root 10 over,
Why'd you put 3? Can you get rid of the 5s?
that's a 5.
Oh, okay.
No, you gotta keep
It
the
looks
5.
like a 3.
That looks like a 3, yeah.
No, it doesn't.
Oh my goodness.
Nothing.
So I just wrote it over one big 5 because they both have common denominators, right?
That's what I did.
What is 5 square root 10 minus square root 10?
4.
4 square root
10 over
10
5.
over 5.
Questions? All right, I believe this is the final example.
We don't have another 8.
Just fit it in. Yes, so square root 3 square root 3 is probably not going to do anything, right? This guy is 5 and 9,
5 and 9.
3 and 3. So 3 square root 5 plus, what should I do in the back? Multiply by the square root 3 over square root 3.
3 over.
And I'm going to put that 3 up top. So 3 square root 3 over 3. Ooh, nice. Yeah, those are going to go away. So I have 3 square root 3 minus 3 square root 5 plus square root 3.
So it'd be 4 square root 3 minus 3 square root 5.
Yep.
Dang, that was easy.
Wait, will you have a square root inside a square root? Probably.
I mean, you can. That's not something you see often. All right, what did we learn about today?
Radicals.
Yeah, honestly, just more radicals. Just crazy stuff you can do with radicals. A lot of fractions today if you want to put fractions on radicals. All right, here comes your homework.